This is a single tooth, 4.2 meters of it, 84 kilos, pulled from a riverbank in northeastern Siberia. It is the longest tusk ever measured on any mammoth. And the animal it belonged to, the woolly mammoth, was still not the biggest of the two animals in this video. By the end, you'll know which one actually was and why almost everyone gets it backwards. Two animals, one you can film today, one that no camera ever recorded. Same family, same body plan, separated by a few million years and by an ice age. Everything you're about to see of the mammoth is a scientific reconstruction built from fossils, frozen specimens, and published measurements. Not footage. Everything you see of the elephant is real. I'll tell you which is which every time it changes, and by the end of this, you'll have the actual numbers from the actual studies, plus the one measurement where the mammoth beats the elephant so completely it isn't close. Here's the trouble. Mammoth is not just an animal. In English, it's an adjective. It has meant enormous since the early 1800s, and it has meant it for 200 years before most people ever saw a measurement. So when you picture a mammoth beside an elephant, the language has already voted. Two skeletons, two published size studies. One of them is heavier, and it is not the one the word points at. What's certain, mammoth is documented in English as a word for huge from the early 19th century. What's reconstructed, whether the Ice Age people who lived alongside them thought of them as giants, is guesswork. Nobody wrote it down. Subject A is not extinct, which means we do not have to estimate anything. We can walk up with a tape. A fully grown male African bush elephant stands roughly 3.0 to 3.4 meters at the shoulder and weighs somewhere between 5.2 and 6.9 tons. Those ears reach close to 2 meters, the largest ears on any animal alive. And they are not for hearing, they're radiators. Blood is pushed through that thin, vein-webbed skin and comes back cooler. This is an animal engineered from the ears down to dump heat. What's certain here? All of it. Every number comes from measuring living animals. What's reconstructed? Nothing. This is the only subject in the film we can actually film. Hold that number. 6.9 tons. Now meet the animal everyone assumes beats it. Subject B. Adult male woolly mammoths averaged roughly 2.8 to 3.15 meters at the shoulder at about 4.5 to 6 tons. Females were markedly smaller, around 2.3 to 2.6 meters and under 4 tons. Look at what that body spends its budget on. Small ears, a short tail, a shoulder hump of stored fat, a double coat of coarse guard hair over dense underfur, and in the mouth, a molar carrying as many as 26 enamel plates. A grinding surface built to process the abrasive, silica-loaded grass of the mammoth steppe until the tooth wore flat. Every one of those is an investment in surviving cold. None of them is an investment in being large. What's certain, shoulder height comes from measured limb bones, and the coat is preserved on frozen specimens. We have the actual hair. What's reconstructed, the body masses are volumetric estimates from restored skeletons, and the color is an inference. A mammoth MC1R gene sequence carried 2 alleles, meaning both dark and light individuals were possible. No fossil preserves color directly. So put them on the same ground at the same camera distance and stop guessing. Same ground line, same lens, same silhouette between them. The ranges overlap heavily. A very large mammoth outsizes a modest elephant. But on the published averages, the African bush elephant is the taller and the heavier animal. 6.9 tons at the top of the elephant range against about 6 at the top of the mammoths. And here's the part that should end the argument. The woolly mammoth was not even the biggest mammoth. The Columbian mammoth on the American plains ran substantially larger. The woolly was the cold specialist of the family, not the heavyweight of it. What's certain, the elephant figures are measured from living animals, the mammoth shoulder heights from real limb bones. What's reconstructed, the mammoth masses are volumetric estimates, so this compares averages and ranges, not two individuals. Which raises a better question than who's bigger. How do we know any of this from an animal nobody ever weighed? A tusk never stops growing. It adds material in nested cones, one inside the next, from birth to death. So the tip is the animal's infancy and the base is its final year. In 2021, a team led by Matthew Wooler took a 1.7-meter tusk from an Alaskan male that died around 17,100 years ago, split it lengthwise, and sampled strontium isotopes in sequence along its entire length. Strontium ratios differ between bedrocks. The plants take up the local signature, the animal eats the plants, the tusk locks it in. Match the sequence against an isotope map of Alaska, and you are no longer looking at a fossil. You are reading roughly 28 years of an individual's movements, the herd years, the prime adult years, and a final more restricted stretch at the end. I'll say this plainly. Of everything in this film, that object is the one I find hardest to believe is real. What's certain, the isotope ratios were physically measured, and the 28 years are counted from growth layers. What's reconstructed, the route on the map, is a model, the best fitting path among many the isotopes permit, not a GPS track. That method also explains why the head-to-head in the title is slightly the wrong pairing. The mammoth's closest living relative is not the African elephant. Nuclear DNA across hundreds of loci puts the Asian elephant as the mammoth's sister species. So the matchup in the title pairs the mammoth with its more distant cousin, and the animal it actually most resembles genetically is the one nobody puts in the thumbnail. And the difference between them was never really size. In 2010, Kevin Campbell's team rebuilt mammoth hemoglobin in the lab from ancient DNA and found 3 amino acid substitutions that let it release oxygen efficiently at low temperature, something ordinary hemoglobin struggles to do when it gets cold. 5 years later, a mammoth version of the temperature-sensing gene TRPV3 was resurrected and tested, and it behaved differently from the elephant version. Small ears, short tail, fat hump, rebuilt blood chemistry. That is not a bigger elephant. That is a different solution. What's certain, the sequences were read from mammoth remains and the proteins tested in a lab. What's reconstructed, what the living animal actually felt in the cold. A protein assay is not a thermometer in a mammoth, which leaves one measurement the mammoth wins outright, the one from the first 15 seconds. Here it is in full, 4.2 meters along the curve, 84 kilograms, from the Kolyma River in northeastern Siberia, the longest woolly mammoth tusk on record. The record African elephant tusk is about 3.45 meters. The mammoth wins, and it wins by a lot. But look closely at how it wins. That extra length is bought with curvature. Mammoth tusks spiral, and in old males the tips arc inward until they almost cross in front of the face. Pull the curve straight and much of the advantage collapses. The mammoth didn't grow a longer tooth by being a larger animal, it grew a differently shaped one. And the last mammoths of all made the point even harder. The population that survived on Wrangel Island in the Arctic Ocean until around 4,000 years ago, long after the pyramids at Giza were finished, stood roughly 1.8 to 2.3 meters at the shoulder, at least 30% smaller than their mainland ancestors. Isolated on a small island, the giant of popular imagination got smaller. What's certain, both tusk records are physical objects that were measured and weighed, and the Wrangel dates are radiocarbon dates on real specimens. What's reconstructed, what the tusks were for. Nobody watched a mammoth use one. So, which one actually wins? On height and on mass, on the published averages, the African bush elephant. On tusk length, the mammoth, comfortably. On being the biggest mammoth, neither. That title goes to the Colombian. The honest answer is that bigger was never the interesting axis. Size in elephants tracks the environment, the food, the climate, the size of the island. Cold made the woolly mammoth hairy, not huge. Which leaves the question I'd actually like your answer to. If the woolly mammoth was never the larger animal, why has mammoth meant enormous in English for 200 years? And what other animal are we still sizing by its name instead of its bones? Tell me below. And if you want the reconstructions we build next, that's what the subscribe button is for.